Hi guys, today we're going to talk about the mole. Now, I know you're admiring my hats. Now, remember that day we had a few days ago where we had to do Disney characters? Well, I'm kind of stuck in the Disney mode here. It was either this, be the blue and brown Where's Waldo, or have you look at my lovely hair. Now, I want to choose the Where's Waldo blue hat, and we'll leave it at that. Alright, so today we want to talk about the mole. Now in chemistry, the mole is a very important concept. We are going to use it pretty much the rest of the year, if not the rest of the year. So you definitely need to understand this concept because it will come in very, very handy. Now, where we want to start with is what is a mole and what are we going to use it for? Okay, a mole is basically just a way of counting. Think of it in terms of like if I asked you, give me a dozen pencils, you would give me 12 pencils. If I said I need a ream of paper, you'd come back with 500 pieces of paper, even though you wouldn't know that's 500 pieces of paper. Just stick with me though. If I said I need a gross of pencils, okay, gross is a counting term. Yeah, it's an old counting term, but it's still a counting term. A gross is a dozen. So you'd come back with 144 of whatever I asked you for. Okay, the mole is just another way of counting. Okay, but we're counting really, really small objects. We're counting molecules, we're counting atoms, we're counting formula units. So we have to use really big numbers when we're counting those, but we're going to put them into smaller terms so we can use them throughout chemistry. Okay, so let's first off talk about what a mole can equal. Now you're going to need to know all these three things. Now sometimes you're going to not know exactly what you're going to. Just read your question. Your question tells you what you're going to. It's going to help you out quite a bit. I don't want to see this number right here, this Avogadro's number, which we use quite a bit in mole problems. I don't want to see this in every problem. Don't be that kid, because I know some of you will be. I'm telling you, don't. Alright, so here's what a mole can equal. The first thing it can equal is the atomic, the molecular, or the formula mass. Now where am I going to get those things from? Okay, I'm going to get those from the periodic table. So if I told you I need a mole of carbon, okay, I'd go to the periodic table. I would see that the molecular mass of carbon is 12.011 grams. That's the formula weight of carbon. It's pretty handy. I can take this number and know that that equals 1 mole of carbon. Now, if I said 1 mole of oxygen, it's not going to be this number. Okay, it's going to have its own number. Now that is 15.9998. Now, I am also going to tell you that that is wrong. Okay, I know you're thinking, why are you telling me this stuff? Because I'm just going to have to erase it. Okay, now remember we have elements like oxygen. Oxygen is one of your German friends. He's a Hofbrinkel. So oxygen should be O2. So we're going to do some practice problems with those, so don't freak out too much about that. But I need to know that that is O2, so that's going to put the number closer to 32 grams. But where do I get that from? I get it from the periodic table. Again, we'll work problems with those. Alright, the next thing we're going to do is in terms of particles. 1 mole can equal 6.02 times 10 to the 23rd particles. Now particles can be a number of things. It can be atoms. So if I want to know how many atoms are in a mole of lithium, I can go to this 6.02 times 10 to the 23rd number, and that's going to be how many atoms I have in it. If I want to know how many molecules of water are in a mole of water, okay, it's 6.02 times 10 to the 23rd. If I want to do a mole of gummy bears, 1 mole of gummy bears would be 6.02 times 10 to the 23rd gummy bears. So we could do that math, and it's pretty exciting stuff there. Okay, the last one is 1 mole can equal 22.4 liters of gas. Now it's very important. Notice I put underlined gas. Don't try to do this with things that aren't gaseous. Only do gases. So if it doesn't have a little G at the end of it after the after the little object, after your compound, after your element, don't do it. Now, this is at STP. What is STP? This is our first time we've really seen STP in anything. This is standard, temperature, and pressure. And I want to give you numbers on those. My standard temperature is 0 degrees Celsius, which is 273 K. That's not degree, that's just K. And our pressure is 1 atmosphere, which is equal to 101.3 kPa. And there's times that we might use either one of those numbers there. Okay, so these are what a mole can equal. We're going to use those now in our problems. Alright, we're back. I've got my handy dandy calculator. How many moles are in 72.9 grams of HCl? Here's how we're going to do that. Okay, the question is how many moles? So my answer is going to be moles. I can look at that and say that's the unit I'm going to end up using. Now, here's what I'm going to start with is going to be grams. So ultimately I need to go from grams to moles. Now let's think back to what we talked about. A mole can equal certain things. Okay, the only one that has grams is going to be my atomic mass. So I'm going to use moles to mass. So here's how I'm going to do that. Or from, mass back to moles. So I'm going to start with what's given to me. The 72.9 grams. Now, chemistry students, you're going to remember dimensional analysis, at least a little bit, I hope. Applied chemistry kids, we're going to work a ton on this so we know what's going on. If I want to get rid of my grams, I'm going to have to put grams on the bottom. So I draw my parentheses, and I put grams on the bottom. Now I want to go from grams to moles. Now I can go directly from grams to moles, so I can put this both in this bracket. Now, I need to figure out how many grams equals how many moles. Now when I'm doing molar conversions, typically what I'm doing at this level, everything that goes in the mole spot is going to be the number 1. That makes it really easy. Okay, so grams, where am I going to get my grams from? Grams come straight off the periodic table. Now you're going to need to go a little bit further into the periodic table and actually look at the numbers. I'm going to give you the rounded off version, so when I put it in here it's really easy, it's really quick. So I looked at the periodic table, I looked to see what hydrogen's mass is. Hydrogen has a mass of 1. Chlorine has a mass of 35.5. So grand total, I have a mass of 36.5 grams. Okay, so math-wise, what I'm going to do is my grams cancel out units, and I'm left with moles. I take my 72.9, multiply it by 1, even though I really don't need to do that because it leaves the same number, and I divide it by 36.5. Wow, look at that. It is the number 2. So 2.00 sig fig-wise, because my calculator answer is 1.997. So now I have 2.00 moles. I need to make sure I put my unit down and circle it. Okay, that's the first problem done. Now let's take a look at another one. Now we're going to go from liters into moles. So let's use our chart that we made earlier and go through that. So what's given to me is I know I need to go to moles. I know I started with liters. So I'm going from liters to moles. So I start with what's given, 11.2 liters. Draw my brackets out. What do I need to cancel out? Liters, so that goes on the bottom. What am I going to? Moles. Now, what I say at this stage in the game, what do all moles equal? All moles equal 1. So I put my number 1 in there. Now, from our chart that we had on the other page, when I first started the video, 1 mole equals 22.4 liters at STP, and this one just so happens to be at STP. Now that doesn't matter if it's CO2 gas or what gas. It could be any gas you wanted. It could be CH4, methane gas. It could be O2, it could be N2. It doesn't matter. It's any gas at STP. So I take this, 11.2 times 1 divided by 22.4, and I get an answer of 0.5. 3 sig figs, 0, 0. And what am I left with? Liters cancel out. I have moles. Okay, problem 2 done. Let's take a look at number 3. Now number 3 looks really, really tough because we're going to grams. The last 2 problems we went to moles, but this one we're going to grams. And we start with molecules. 1.204 times 10 to the 24th molecules. So let's see what we have here. So I'm going from molecules into grams. So here's how I'm going to start it off. I'm going to start off with what I know. 1.204 times 10 to the 24th molecules. And I draw my brackets. Now, I want to get rid of molecules, so the only way I can get rid of molecules is to put it on the bottom. Now, I don't want to go from molecules to moles, I want to go from molecules to grams. Now, if we think back to our little chart though, there was nothing on that chart that said molecules into grams. So I have to find what's common to both of them, and that is the mole. So I'm going to go mole. Now, according to that chart, 1 mole, once again notice we're using 1 for mole, equals 6.02 times 10 to the 23rd molecules. It's pretty handy. Now, I don't want my answer to be in moles though, so now I need to go from moles into grams. So now it's mole into grams. And 1 mole, once again we're using 1 for mole, and grams, what I'm going to do is, carbon has a mass of 12. I have 2 of them, so that's 24. I have 4 hydrogens, they're 1 apiece, so that's 28. And I have 2 oxygens, which are 16 apiece, so I have a grand total of 64 grams. Now to solve this, I'm going to take it across the top. 1.204 times 10 to the 24th times 1 times 64. That gives me a number, and I'm going to take that number and divide it by my 6.02 times 10 to the 23rd. Gives me 128 grams. Now, this is a 2-step problem, and I know some of you are thinking, wow, that's the longest problem I've ever done in my life. They're going to get longer. This isn't that difficult. You just have to go step by step. One other thing I wanted to cover right before I leave. See how I have moles right here? Notice I didn't abbreviate moles. Notice I didn't abbreviate molecules. Here's why. When they abbreviate moles, they take a 4-letter word and change it into a 3-letter word. So this is abbreviation for mole. A lot of you are going to look at MOL and think it's molecule. No, molecule doesn't have an abbreviation. They write molecules all the way out, yet abbreviate the 4-letter word. So, don't let that confuse you. We're going to have lots of problems over these, and I know you're looking forward to it. So we'll see you when you get back.